Welcome. I've got Straight Up at 6 o'clock p.m. Central Time here on this Wednesday evening. I'm so glad that you guys decided to get on this Nrf2 webinar. This is for the people that really want to dig deep into the science behind Nrf2 and why it's become such a phenomenon, frankly, in the medical world, at least with regard to the anti-aging medical practices. It's really starting to become a buzzword. And I'll talk a little bit about that, what's been going on recently in that whole arena. My name is Mark Gordon. I'm a board-certified cardiologist, and I've also completed a fellowship in anti-aging and regenerative medicine. And just within the last couple of years, the whole Nrf2 thing has really come to the forefront in the world of anti-aging and regenerative medicine. You've probably seen a recent newspaper article about some studies that have been done at Oregon State University. I'll talk about that towards the end as well. But I'm very pleased that you guys are all on here tonight. I do have this one piece of housekeeping that we need to take care of, and that is that this is for educational purposes only. No photographs, video, or audio recordings, please. So to have a background understanding about Nrf2, we really need to go back and talk about oxidative stress and what that is. And oxidative stress can be defined as an imbalance between the production of reactive oxygen species, or free radicals, and the antioxidant defense system. And if we take a look at this slide here, the things that we see in red or orange, colorblind, so forgive me if I get the colors wrong. But the things that we see here, superoxide anion, peroxynitrite, hydroxyradical, and hydrogen peroxide, are the primary free radicals that cause damage to our cells. And it depends upon what part of the cell that they happen to hit. They can damage the membranes of the cell. They can damage the lipids of the cell. They can damage the mitochondria, the powerhouses in the cell. They can damage all of the other organelles within the cell, and they can also damage the DNA in the nucleus, which can lead to mutations and subsequently tumors and cancer and so forth, which is obviously the worst thing that we could have happen from the free radical damage that occurs. So the way that these free radicals are produced is just basically what happens with oxidation, taking oxygen into your body, and the subsequent chemical reactions that occur, ultimately taking it back to oxygen and water. And as you can see here, there are certain enzymes that are critical in the process of this conversion from potentially toxic damaging compounds to basically inert compounds here, water and oxygen. So superoxide dismutase is important for this conversion of the superoxide anion to hydrogen peroxide. And then glutathione and catalase are critical for converting hydrogen peroxide to water and oxygen. And so you can imagine that if you are lacking in those things, or your levels are way low, you're going to have a buildup of a significantly higher number of these toxic free radical molecules. And so you want to really drive the chemical reaction to water and oxygen. And if you've got good levels of SOD, catalase, and glutathione, that's exactly what's going to happen. But if you're depleted in these things, you're going to have more free radical production just through the normal process of metabolism. So eating food causes free radical production, but in addition to that, we're exposed to all of these outside sources of free radical production that ultimately leads to the oxidative stress. Smoking, alcohol, pesticides, insecticides, herbicides that we spray on our crops, inflammation, poor diet, pollution, drugs, radiation. People that work in cath labs, like I used to until recently, had significant radiation exposure, and I used to wear lead from my neck down to my knees to cover vital organs, but there were multiple areas of my body that were not covered. And interestingly, in one of my anti-aging courses, we had an interventional cardiologist speak, and he was a very fit, very health-conscious individual, and didn't eat anything bad, didn't put anything bad into his body. He was a marathon runner, did all of the right things, and he went and had a carotid ultrasound, or more precisely, a carotid intimal medial thickness test done. And he found that his carotid artery on the right side was completely normal, but the carotid on the left side already had atherosclerosis in it, and the guy was in his mid-50s, I would say. And so he started to ponder that, and he figured out that the only thing that could have done that was the fact that he was in the cath lab all of those years. And when you're in the cath lab, you're standing on the patient's right side. Their head is to your left, their feet are to your right as you're doing the angiograms, and the x-ray tube is right above their chest. So the x-ray tube, is basically bombarding his left carotid artery, and it was causing inflammation, oxidative stress, and ultimately plaque formation in the wall of that vessel. And so he's out of that world now. He's not doing any coronary interventions anymore. He's just practicing preventive medicine. But that just goes to show you how much damage things like radiation can do, things that we really don't think that much about. So if you're in the healthcare profession and you do have significant radiation exposure, it's something that you need to be cautious about. Physical and emotional stress, injury, trauma, aging itself increases oxidative stress levels, infection, too much and not enough exercise. Now, if you look at all of the things that are associated with free radical damage and oxidative stress, the list is basically everything that you hear that old people get that you don't want to get. And you could look at every organ system that's out there. The heart, myself being a cardiologist, obviously I think that's the most important, and that's why I put it at the top. Myocardial infarction, heart attack, hypertension, myocardial ischemia, cardiac fibrosis, coronary heart disease, in the skin, melanoma, skin cancer, psoriasis, sunburn, skin aging, dermatitis, in the kidneys. Chronic kidney disease is very closely linked to oxidative stress. In the joints, just about every type of arthritis that you can think of, from rheumatoid to osteoarthritis to psoriatic arthritis, all of those things are rooted in oxidative stress. In the lungs, asthma, COPD, allergies, ARDS, lung cancer. In the brain, Alzheimer's, Parkinson's, ADHD, autism, migraines, brain cancer. My father died of a brain tumor about not quite 2 years ago now. In the immune system, chronic inflammatory conditions like lupus, rheumatoid arthritis, inflammatory bowel disease, things like Crohn's and ulcerative colitis, multiple sclerosis, immune system cancers. In the blood vessels, atherosclerosis or plaque buildup in the arteries, as I was telling you with that cardiologist, restenosis or re-narrowing inside an already stented or ballooned vessel, that perhaps a patient came in and had a coronary stent put in. 6 months later, they come back and that same spot is re-narrowed. Well, what happened there? It was an inflammatory process that led to that restenosis. And unfortunately, it's not something that's easily predictable by currently available testing, whether somebody's going to be prone to that restenosis. Endothelial dysfunction. The endothelium is the lining of the blood vessels, and that's the first thing to go when you start to develop either hypertension or atherosclerosis. And there are some very good non-invasive tests of endothelial function that you can do. One is called the EndoPAT test. It's ENDOPAT. It's a non-invasive test of endothelial function, and we've had some dramatic results in individuals taking Nrf2 activating compounds compared to a set of controls that also were on very good, healthy diets. Multiple organs, diabetes, aging, chronic fatigue syndrome, all of those things are affected by oxidative stress in a negative way. Macular degeneration and retinal degeneration and cataracts additionally are caused or significantly affected by oxidative stress. So this list isn't a complete list, but it kind of gives you an overall idea of what the things are that people get as a result of oxidative stress over the years that they're alive. And so in the past, historically, the way that we have tried to deal with this problem of oxidative stress is by taking antioxidants. And we're all familiar with vitamin E, vitamin C, beta-carotene, and all of the other direct antioxidants. These are antioxidants that you take in from the outside. And so the way that these antioxidants work is an antioxidant molecule comes in close proximity to a free radical. The free radical is missing an electron from its outer shell, and the antioxidant donates an electron to neutralize that free radical. Well, that's well and good, but the problem is it's one and you're done. One antioxidant molecule neutralizes one free radical molecule and the process is over. And we used to think that this was a good approach to take until we started seeing studies come out, and this is just some of those studies, showing that taking, amounts of these vitamins above and beyond the U.S. Recommended daily allowance may actually be harmful. Vitamin E can increase the risk of prostate cancer in this study. Antioxidant supplements may increase the risk of skin cancer in women. Vitamin E and beta-carotene may increase lung cancer in some patients. There's other studies that show that it may increase the risk of heart disease. So why is that? It seems like a paradox that you're taking something that's supposed to be good for you, but yet it's actually making the problem worse. Well, it's been theorized that these antioxidant molecules, as they donate electrons to neutralize free radicals, they themselves become depleted of electrons in their outer shell, and therefore they turn into free radicals. So you can imagine if you've got a ton of, say, vitamin E floating around in your system, and it's attacking the free radicals or it's neutralizing the free radicals, you're going to set off a chain reaction where that antioxidant molecule that just neutralized a free radical is going to go try to fill its outer shell and steal electrons from wherever it can. So what you were taking as an antioxidant suddenly turns into a pro-oxidant. So the idea of taking large quantities of these types of direct antioxidants has really fallen out of favor, especially in the anti-aging world. We recognize that that is not an effective way to take care of the problem anymore. So these direct antioxidants cannot neutralize free radicals as efficiently as indirect antioxidants. The things like the things like superoxide dismutase and catalase and glutathione don't work in the same manner as these direct antioxidants. SOD catalase and glutathione, for example, are called indirect antioxidants. They are produced in the cells in our body in response to certain signals. And these are very large molecules, they're enzymes, and they have the capabilities of literally neutralizing up to 1 million free radical molecules before they get consumed, and they don't turn into free radicals themselves. And so that's why it's been found more recently that it's better to have your body make its own antioxidants rather than try to take extra ones in from the outside. And so it was discovered in 1994, I believe, 95, right in there, this particular protein called Nrf2, which is a transcriptional protein. It's a messenger protein. And what it does when it gets activated is it goes into the nucleus of the cell. It translocates from the cytoplasm to the nucleus, and it attaches to a specific segment of DNA. And I'll show you that in just a moment, a schematic drawing of that. But this Nrf2 is critically important in redox balancing, and it is really a master regulator. So if we look at this next slide here, this kind of depicts what happens. So if you have a Nrf2 activator that attaches to the cell surface, the membrane, the receptors on the cell surface, there is this molecule called Nrf2 that is held in place by another molecule called keep1. And keep1 is held by a strand of actin, which is kind of the cytoskeleton of the inside of the cell membrane. So the Nrf2 is being held in the cytoplasm near the cell membrane, and then when a Nrf2 activator acts on the cell, Nrf2 gets released. And then what it does is it translocates, as I said, from the cytoplasm into the nucleus, and it attaches to a segment of DNA called the antioxidant response element. What happens at that point is all of the genes downstream on that strand of DNA are affected in either a positive or a negative fashion. It depends upon what those genes code for. In a nutshell, what happens is the antioxidant, anti-inflammatory proteins are upregulated, and the pro-inflammatory, pro-fibrotic proteins are downregulated. So you get more of the good and less of the bad, more of the anti-inflammatory, anti-fibrotic, and less of the pro-inflammatory, pro-fibrotic. The net result of that is a significant reduction in oxidative stress. Now, along this Nrf2 pathway, there are plenty of places that you could potentially act upon it to cause it to be upregulated. If we go back to this last picture here, and this slide just kind of depicts many of the different locations where they've used as targets to try to help activate that Nrf2 pathway. But if we go back to this more simplistic picture, you could imagine that if you have a Nrf2 activator that perhaps helps the release of Nrf2 from KEAP1, that could activate the pathway. Or if you have something that helps to cause it to go from the cytoplasm into the nucleus, that's another place where it could be effective. Or perhaps there's something that may help it attach to this antioxidant response element. Interestingly, Nrf2 actually activates production of itself. The gene for Nrf2 is downstream on this strand of DNA after the antioxidant response element. So Nrf2 actually upregulates itself when it attaches to the DNA. And so the other thing that's interesting about Nrf2 is it is in some respects a physiologic response in that certain things like adequate amounts of exercise can help to activate Nrf2. And Nrf2 is activated in a pulsatile fashion in a normal physiologic state. It's not turned on all the time. It's not off all the time. If it's either on or off all the time, it can actually lead to health problems. And there are certain types of health conditions that can kind of hijack the entire Nrf2 KEAP1 pathway and have it turned on 24/7. And one thing in particular is cancer. And it's important that we touch on that because there's a lot of misconceptions about the effect that Nrf2 may have in cancer. There's articles out there that are titled things like The Dark Side of Nrf2, and it talks about this whole issue of cancer. So let's touch on that for just a moment. Certain cancer cells, through their mutations, actually will mutate Nrf2 or KEAP1 so that Nrf2 is turned on all the time. And it's theorized that the reason why that happens is the cancer cells are trying desperately to perpetuate themselves, make them live as long as they possibly can. And so it helps to do that by activating Nrf2 and keeping it on 24/7 to try to help protect those cancer cells. So some people have jumped to the conclusion that activating Nrf2 in a situation like that may actually be bad, and it may actually increase the likelihood that the cancer is going to metastasize or grow bigger or whatever. And we don't really have any clear evidence that that's the case. Other studies have suggested that perhaps a more accurate depiction of what is happening is something like this. The cancer cell is trying to protect itself, so it activates that Nrf2 within the cancer cell. But the cells around the cancer cell that are currently not cancerous, they potentially could have protection from Nrf2 activation. The jury is still out on that, so we tread very lightly in the cancer arena. If somebody has cancer, I always tell them that they should check with their oncologist as to whether or not Nrf2 activation would be contraindicated in their treatment regimen for their particular type of cancer. And certainly if people are taking chemotherapy or radiation therapy, we generally tell them not to take a Nrf2 activator during that time. Ask their oncologist if it's okay that they take it when they've completed that therapy. So this slide kind of shows the explosion of the research that's happened in Nrf2. And if you go out and you talk to 100 doctors on the street, you're going to be lucky if you can find one that has even heard about Nrf2. And here's the reason why. Nrf2 was actually discovered, I believe it was in 1994, and there were not a lot of studies done until the early 2000s, and then there's just been an explosion of studies, and by the end of 2014 there were over 5,000 studies. So people in the research community are quickly recognizing that activating this Nrf2 pathway can have profound effects on a variety of different diseases and health conditions. And that's why there's been such a flurry of research and why pharmaceutical companies are now spending hundreds of millions of dollars on research and development of synthetic Nrf2 activating compounds. This is one particular study that talks, I had mentioned earlier, perhaps maybe not in this talk, but in another one, one of the problems as we age is our Nrf2 becomes less active, and subsequently we produce less of those protective antioxidant enzymes, the SOD, the catalase, the glutathione, and others. And this is a study that just actually proved that Nrf2 declines with age, and it induces oxidative stress. So the decline of Nrf2, or the decreased activity of Nrf2, actually induces more oxidative stress. So what we're trying to do with Nrf2 activation is make our cells function as they did when they were younger in activating that Nrf2 and giving them that protective edge against the oxidative stress and the free radicals. Now, as I mentioned, pharmaceutical companies are spending literally hundreds of millions of dollars on research and development on synthetic Nrf2 compounds at this time. And this is just a list. It's not a complete list, but these are some of the companies and some of the universities that currently hold patents on synthetic Nrf2 activating compounds. Currently, Biogenetic has the only FDA-approved Nrf2 activating agent. It's called Tecfidera, or dimethyl fumarate. It was studied and found to be extremely effective in preventing relapses of multiple sclerosis. And because of that, and a landmark study that was published in the New England Journal of Medicine, they got FDA approval. In their first year after that drug had been in use, they sold $3 billion worth of that drug. And that particular drug is about $50,000 a year for an individual to take. But it's not just pharmaceutical companies that are getting on the bandwagon. Abbott and Reata have partnered up. Reata is a small biotech company. They partnered with the giant Abbott Pharmaceuticals to help with marketing. And Reata has a pipeline full of Nrf2 activating compounds that they're studying in a variety of conditions, from COPD and kidney failure now to pulmonary hypertension. CureVita has a drug that they're studying in Crohn's disease and ulcerative colitis. And then all of these other companies and universities have other things that they're studying. And the list of research is nearly endless. As you can imagine, when you first hear about a new drug or a new pathway, and then you start to hear of all of these different conditions that are being studied, you start to wonder, is this too good to be true? There's no one pathway that can affect so many different things. But when you begin to recognize how many things are caused by oxidative stress itself, and what you're effectively doing is you're getting to the root cause of so many different problems, that's why it can have such a broad effect on so many different conditions. And that's why the pharmaceutical companies are now studying it in so many different disease states. And these are some of the articles of some of the studies that have been done with an all-natural Nrf2 activator called Protandim. And these are from some fairly reputable journals like Circulation, the Journal of the American Heart Association. And Protandim is an all-natural supplement that has 5 ingredients: bacopa, ashwagandha, turmeric, green tea, and milk thistle. None of them are too exciting by themselves, but what they found in the research was that there was this gigantic synergistic effect. And if you look at the increase in the expression of the antioxidant genes with the combination, if you look at the individual ingredients, there's really not much of an effect. The milk thistle had maybe a slight effect, but when they put the 5 together, there was an 18-fold increase in the expression of these antioxidant genes. So it wasn't by chance that they stumbled upon these 5 ingredients. They started researching them individually and then putting them together in pairs and groups and so forth. And they found that this combination of these 5 and the ratio that's in Protandim gave it the most bang for the buck, an 18-fold increase in the expression of those antioxidant genes. So the first study that was done on Protandim was this one here at the University of Colorado. And they had some very interesting findings. They found that after 120 days, the increase in SOD in the human body was 34%. Catalase increased 54%. And then when they looked at the measures of oxidative stress, look at this slide here. What's interesting, and there's a couple of points I want to point out. So this line in the middle here was the baseline of the level of oxidative stress measured by those T-bars from individuals from the age of 20 to 80. Okay, so this was their baseline. And then they broke it down further into those that were taking no supplements and those that were taking vitamin E and vitamin C. And what they found, it was not statistically significant. The R value was not statistically significant, but there was a trend towards increased levels of oxidative stress in those people that were taking vitamin E and vitamin C, which supports the theory that I was talking about earlier, why taking large doses of those things may actually cause you to have a pro-oxidant effect as opposed to an antioxidant effect. And so what they did is they took all of these individuals and they put them on Protandim for 30 days. And what they found was that by the end of the 30 days, there was an average reduction in oxidative stress of 40% across the board. By the time they were done, the samples of blood that they took from the 80-year-old looked just like the samples that they were taking from the 20-year-olds. So it really did an effective job at reducing oxidative stress, and that led the FDA to grant the company LifeVantage the approval to make the statement that they reduced oxidative stress in humans by 40% on average in 30 days. This is an article that I love to point out to people, especially in the healthcare arena. This came out just about a year ago, and it's a review article about all of the studies that have been done on Nrf2 activation and specific disease states. And I'm going to go through some of the data that they covered in this study because it was really quite profound. So the genes that are activated by Nrf2 aren't just the genes that code for superoxide dismutase catalase and glutathione, and those are the ones that we talk about the most, but there's actually over 500 genes that are upregulated. There's another messenger protein called Nf-kappa B, which when Nrf2 is activated, Nf-kappa B becomes less active. So there's this crosstalk between the two. So Nrf2 downregulates Nf-kappa B. Nf-kappa B is what's responsible for all of the pro-inflammatory, pro-fibrotic effects. And so by reducing Nf-kappa B, that's what causes the reduction in the in the pro-inflammatory gene products. And then there's some other repression of some other genes through other transcriptional effects. But one of the big things that has been found with Nrf2 activation are these cytoprotective effects. And it's not just the antioxidant enzymes that I had mentioned, but there's plenty of other proteins here that protect against various and assorted types of oxidative stress challenges to the cells. I'm not going to go through these in any great detail, but glutathione is the one that is probably the most widely recognized and the one that's most important in detoxification. I'll spend a little bit of time talking about that. So in looking at the studies that have been done on cytoprotection, what they have found is that there's a reduced susceptibility with Nrf2 activation to many types of cancer. There is improvement in neurodegenerative conditions. There's improvement in chronic lung disease conditions. There's improvement in patients that have liver and GI problems. And there's a marked reduction in inflammation. Now, I had mentioned about the glutathione and the detoxification effects. Glutathione levels have increased in some studies up to 300% with activation of Nrf2. And there's many other enzymes that are involved that get upregulated by Nrf2 that help to detoxify other compounds like xenobiotics and so forth. There are actually 5 genes that are involved or that are upregulated that affect glutathione when Nrf2 is activated. And then there's these other enzymes that are important with heavy metal detoxification. And it's interesting, many people, I've spoken to literally thousands of people about Nrf2, and very, very few people had any clue what it was before I spoke with them about it. One of the individuals that did know about it before I spoke to him was actually my brother, who's a PhD toxicologist at 3M. And the way in which he knew about Nrf2 was its importance in detoxification from heavy metal poisoning. He said that he had heard many talks on that as his role as a toxicologist. So we talk about detoxification and the importance of this. And part of the problem that people may have initially when they start taking a Nrf2 activating compound is a small percentage of people actually go through a detoxification reaction when they start taking it, where they start to pull these toxins into their bloodstream out of their fat stores, and as they do so, they may feel sicker before they feel better until they get rid of those toxins. The glutathione we've mentioned dramatically increased with Nrf2 activation. Some studies suggest up to 300%, and it's clearly been singled out as the most important detoxification enzyme in the human body. It also helps to regulate the nitric oxide cycle, which may explain some of the side effects that some male individuals like from taking Nrf2 activating compounds. And it's also, glutathione is also involved with DNA repair. So those damages, the damage that occurs from oxidative stress to those strands of DNA and the mutations, glutathione can help repair that. It's involved with protein synthesis and other enzyme activation. And every organ system in the body is affected in some way by glutathione. Now, going back to medical school here, there are two phases of detoxification that compounds go through, phase 1 and phase 2. And so when you take in something that isn't supposed to be in your body, some toxin, it has to go through initially the cytochrome P450 system in phase 1 of detoxification, and there's many different things that affect cytochrome P450, including many drugs. And then you get conversion of that toxic molecule into an intermediate molecule, some intermediate agent, and then phase 2 kicks in, the conjugation pathways, and that intermediate molecule is then converted to something that you can get rid of in your urine, bile, or your stool, and generally that is a much less toxic compound that gets eliminated from your body. Here's one of the problems that can happen. You have to have phase 1 and phase 2 both working in harmony, and if you don't, things get out of control. Because if phase 1 works and phase 2 doesn't, you get a buildup of these intermediate molecules, most of which are actually more toxic to your body than the original molecule that you took in. So you can imagine if you've had years and years of phase 1 working and phase 2 hasn't been working, you've got all of these toxic molecules, and where do they sit? They sit in your fat stores throughout your body. So if you start taking something that increases the activity of phase 2, you start pulling all of these toxic molecules out of the fat stores. They get into your bloodstream before they're ultimately eliminated through your body. But as they get into your bloodstream, that's where you have what's called the detox reaction, where people start to feel sicker before they get better. Now, one of the key components of both phase 1 and phase 2 is glutathione. Now, you can have phase 1 work to some degree without glutathione, but it's definitely necessary for phase 2. So that's why I say if you've got phase 1 working and phase 2 doesn't, there's a higher than likely chance that you're probably going to have a detox reaction as you start taking a Nrf2 activator, as you start increasing production of glutathione. But once you finally get rid of all of that stuff, and you keep the Nrf2 active and you keep the glutathione levels high, you shouldn't have continued problems with that. We talk a lot about the anti-inflammatory effects. Most people that have inflammatory conditions do notice improvement with Nrf2 activation, and there's multiple pro-inflammatory genes that are actually suppressed through that Nrf-kappa B compound that I talked about. Those include tumor necrosis factor alpha, interleukins 1 and 6, cell adhesion molecules, prostaglandin metabolites. All of these things are very active in people with chronic inflammatory conditions. Okay. Now, one of the other things that Nrf2 does is it actually stimulates production of interleukin 10, which is an anti-inflammatory cytokine. So Nrf2 does all of the good stuff. It increases the anti-inflammatory, decreases the pro-inflammatory in pretty much every study that you look at. It's also been found to be beneficial in many chronic inflammatory conditions and disease states. And this chronic inflammation is implicated in the pathogenesis and progression of all of these different diseases, including neurodegenerative disease like Parkinson's and Alzheimer's and so forth. Pulmonary fibrosis is a big one as well. Mitochondrial biogenesis. The mitochondria are the powerhouses of the cell, and one of the things that Nrf2 activation does is it stimulates mitochondrial biogenesis. It increases the production of the mitochondria, keeps them healthy so they can continue to form the energy for the cells to work. And there's another pathway called AMPK, adenosine monophosphate kinase pathway, that is also an anti-aging pathway in a sense. And there's crosstalk between Nrf2 and this AMPK pathway that helps with that mitochondrial biogenesis and keeps the energy levels of the cell high. Another thing that Nrf2 does is it stimulates this autophagy. And what that is getting the bad stuff out of your cells, the damaged cell parts, the damaged molecules, the junk that's floating around in your cells. And this junk that floats around in your cells has been implicated as one of the causative factors in neurodegenerative conditions like Alzheimer's and Parkinson's. So getting rid of that stuff can obviously be very beneficial. As antifibrotic effects, these have been studied in the liver, lung, and the kidneys. Won't go into a great bit of detail about that, but the studies are there and you can go look them up for yourself. And then cellular integrity. One of the things that Nrf2 does is it helps to keep the cells intact, and it does that with its effect on this tumor suppression transcription factor, which is one of the things that was studied in one of the studies, or two of the studies actually, with regard to protandim and melanoma skin cancer. There have been numerous studies looking at the activity of Nrf2 and longevity, and the bottom line is that what they found is that those species that have higher levels of Nrf2 tend to live longer than similar species that have lower levels of Nrf2. Neurodegeneration. This is an area that's very, very active in research right now with Nrf2. And any type of traumatic brain injury like concussion and so forth, Nrf2 is absolutely essential to help that brain heal. And it's also been, Nrf2 has also been found to help decrease cell death, nerve cell death in patients with Parkinson's and Alzheimer's. It helps in protecting neighboring cells around the astrocytes from the damage from oxidative stress. And in mice, they have found that the reduction of Nrf2 is responsible for the age-related cognitive decline. So the things that have been looked at with Nrf2 in the brain include Parkinson's, Alzheimer's, ALS, traumatic brain injury, multiple sclerosis, and nerve cell protection. And there's dozens of studies looking at these different things. This particular one talks about Nrf2 being a multi-organ protector. This one talks again about the degenerative and immunologic effects, or the effect of Nrf2 on degenerative conditions and immunologic conditions. And this study in particular looked at Parkinson's and Huntington's chorea, as well as stroke. And what they found was that Nrf2 has been shown to play an important role in mouse models of neurodegenerative diseases such as Parkinson's and Huntington's. And additionally, Nrf2 has been reported to be relevant in acute neurological disorders such as stroke. Oxidative stress plays an important role in these neurodegenerative disorders, including the degeneration of the dopaminergic neurons in Parkinson's disease. So this is an area that's really hot in research right now. I had mentioned about the role of phase 1 and phase 2. Okay, Nrf2 is important in that phase 2, which also helps with neuroprotection. Here they talk about KEAP1 and Nrf2 as being potential therapeutic agents for a variety of conditions, including cancer, neurodegenerative disorders, cardiovascular disorders, metabolic and inflammatory disorders. And the articles just keep going on and on. Here again, neurodegenerative diseases are being studied with Nrf2. This is just a list of some of the companies and some of the universities that hold the patents on synthetic Nrf2 activating compounds. and the things that they're studying them in. And it's pretty amazing to go and look at the research. So these are some molecules that we know that activate Nrf2. I talked about for tandem there's 5 plant-based ingredients, and there was a synergistic effect. Some of these molecules are synthetic, some are naturally occurring. Curcumin or turmeric, naturally occurring. These others are synthetic. So what about traumatic brain injury? Well, what they have found is that the blood-brain barrier is oftentimes disrupted in traumatic brain injury, and Nrf2 activation can help protect and restore that blood-brain barrier. And it also has anti-inflammatory effects, and they believe that that's probably why it's been found to be beneficial in traumatic brain injury. Ischemic stroke and hemorrhagic stroke, the difference is ischemic is lack of blood flow, hemorrhagic is you bleed into the brain. Bottom line, it's been found in animal studies to be protective in both types of stroke as far as recovery after a stroke, either hemorrhagic or ischemic. In Parkinson's disease, this is an area that's being studied a lot with regard to Nrf2 activation. And it's been found that Nrf2 may help to stop that neurodegeneration in Parkinson's by a variety of different methods, including increasing glutathione levels. It seems as if most of the neurological conditions really derive a great deal of benefit from Nrf2 activation due to the effect of increasing glutathione levels. Cerebral inflammation, again, traumatic brain injury, Nrf2 activation has been found to be protective and beneficial. This is from the Michael J. Fox Foundation, and he had initially been spoken to, I'm told, about Nrf2 activation, potential therapy in Parkinson's disease, but didn't get on board right away. But more recently, he did. Their foundation did get on board with studying Nrf2 activation as a potential treatment for Parkinson's disease, and they have a clinical trial ongoing right now with a synthetic Nrf2 activating compound. More studies on Parkinson's and Nrf2. How about Alzheimer's? Well, one of the problems in Alzheimer's is Nrf2 is actually dramatically reduced in the hippocampus portion of the brain. And they found that increasing Nrf2 activity helps to reduce the cell death in those neurons, in those nerve cells in the hippocampus, and it can also help protect the brain against vascular dementia. And what that is over a long period of time, the micro vessels in the brain may get plugged up, decreasing blood flow to small parts of the brain. So you basically have these micro strokes all over in your brain. And Nrf2 activation may be beneficial in protecting the brain against that. Now, one of the studies that was done with Protandim looked at the effect of Protandim on the genes associated with Alzheimer's. And I'll point out here that Protandim is not a drug. It's an all-natural compound. It's a nutraceutical. And as such, the FDA does not allow any disease-specific claims of cure, treating, preventing, or mitigating any particular disease. But what I can show you is the results that they found with the effect of Protandim on the genes associated with Alzheimer's disease. So there's actually, I believe, 66 genes. If we go to the next slide here, yeah. And Protandim had a positive effect on 43 of the 66, or 65% of the genes. So meaning that if a gene is downregulated when you have the disease of Alzheimer's, Protandim upregulates that gene and vice versa in 65% of those genes associated with Alzheimer's. And so there's, again, a lot of research going on and looking at this Nrf2 activation in Alzheimer's disease. Multiple sclerosis. As I mentioned, Tecfidera, the drug from Biogenetic, has FDA approval as a Nrf2 activator to treat multiple sclerosis. And let me just show you the results of their studies that got them FDA approval. The DEFINE trial looked at Nrf2 activation with dimethyl fumarate, that's Tecfidera. And they found over 2 years that there was a 49% reduced relapse rate of MS in those individuals. And there was also significant reduction in new lesion formations in the brain. They did a corroborative study then called the CONFIRM trial, and in that particular study they found a 44% reduction in relapse rates. So that was quite significant, basically a 50% reduction in relapse rates with that drug. One of the studies that was done with protandim from the University of Colorado looked at the Nrf2 activation of protandim and also several of the other known Nrf2 activating compounds. And this slide nicely shows that. It shows a couple of things that I'll point out. First is protandim was compared to bardoxolone. This is a drug from from Reata and Abbott Pharmaceuticals. And then this is dimethyl fumarate, or Tecfidera, the drug that Biogen has for multiple sclerosis. And then this is sulforaphane, which is the active ingredient in broccoli, which is also a Nrf2 activator. So the first thing that I'll point out is each of these agents, all of these Nrf2 activators, have this hormetic response in that they have a peak effect at a moderate dose, and when you go to higher doses, you actually get less of an effect. And it doesn't matter which of the agents that you're talking about, they all have that effect. You go to higher doses, you get less effect. So taking more of something isn't going to give you more of an effect. In fact, it may do just the opposite. And then the second thing I want to point out is protandim had the highest level of Nrf2 activation compared to any of these things. It had twice the level of Nrf2 activation as bardoxolone, twice the level of Nrf2 activation as Tecfidera, and 6 to 7 times the activation compared to sulforaphane. So that's pretty profound. And so I didn't really understand why this would be when I first saw this study, because usually when there's synthetic compounds that activate the same pathway as some natural thing, usually the synthetic compounds are much, much more potent. And so I asked Dr. McCord, who did this study, I said, explain to me why it is that protandim would have such a higher level of Nrf2 activation than those synthetic compounds. And he said it has to do with the fact that because this is 5 plant-based ingredients working synergistically, they're probably acting to activate that Nrf2 at several different points in the pathway. Remember in the beginning of the talk, I talked that there were multiple locations where you could activate the Nrf2. Well, the individual ingredients protandim probably do that in a synergistic fashion, and that's probably why there was more Nrf2 activity. Now, that particular study was done at the University of Colorado by Dr. McCord, so some people may think that it's a biased study. So just to show you that other researchers found the same effect, I'll bring to your attention this particular study. It was presented in Amsterdam at a World Congress on multiple sclerosis for treatment and research in MS. And this particular study looked at Nrf2 activators as a novel strategy to protect oligodendrocytes in multiple sclerosis. And what I want to bring to your attention is their results and their conclusions. And they compared BG12, which is Tecfidera, to another synthetic Nrf2 activator, to sulforaphane, the ingredient in broccoli, and protandim. So they compared those 4. And here's what their results were. Our findings indicate that several Nrf2 activators are able to significantly increase antioxidant enzyme production in oligodendrocytes. Interestingly, protandim, a dietary supplement consisting of herbal ingredients, was the most potent inducer and therefore may be the most suited as a therapeutic strategy. This particular study was funded by Biogen, the company that makes Tecfidera. So they pointed out that protandim, most potent inducer, and therefore may be the most suited as a therapeutic strategy. That was pretty good validation from my perspective. So lots of studies looking at the effect that Nrf2 has on survival of not just nerve cells, but pretty much every type of cell. Huntington's disease has promising research with Nrf2 activation going on right now. ALS, there's some active studies going on right now. I was recently contacted by a major ALS researching organization that is interested in doing studies of Nrf2 activation in ALS. some human clinical trials that we're working towards. Altitude sickness, Nrf2 activation has been found to be very beneficial. This was a study that actually looked at proteanum, and they found that it could help reduce cerebrovascular leak, which is what's responsible for acute mountain sickness. And anybody who's had this, you know how horrible it can be. I had the very early stages of this when I tried to climb Long's Peak after I drove from Minnesota to Colorado and didn't take any time to get acclimated to the elevation. It's nasty. You don't want it. I wish I would have had a Nrf2 activator before I made that climb. This is a very interesting study. Now, one of the things that people who take Nrf2 activating compounds have said to me over and over is, gee, it seems like when I go out and drink, I don't feel hungover the next day. And this may be why. They found that Nrf2 can actually protect cerebrocortical neurons from ethanol-induced apoptotic death. So it may help prevent the death of the brain cells. So here's what they found. These studies illustrate the importance of Nrf2-dependent maintenance of glutathione homeostasis and cerebrocortical neurons in the defense against oxidative stress and apoptotic death elicited by alcohol exposure. So just one more benefit of taking a Nrf2 activating compound. This is another study I like to point people to called Nrf2, a Guardian of Health Span and Gatekeeper of Species Longevity. It is a study that looks at the different organ systems and how they are affected specifically with Nrf2 activation, and also how that translates into species longevity, and not just that, but lengthening the amount of time that an individual is healthy before they ultimately do pass away. And so this is from the conclusion of that study. There's mounting evidence across evolutionary distinct species that Nrf2-dependent components are associated with both longevity and extension of health span. And for those of you guys that are interested in the effects on specific organ systems, that is one of the studies that I would read cover to cover. It's a very, very good one. In that first study that I talked about from Washington State University from February of 2015, this table comes from there, and this is basically a summary of all of the diseases that have been studied with regard to Nrf2 activation, where they found that raising Nrf2 may be beneficial, including cardiovascular diseases, atherosclerosis, ischemic cardiovascular disease, endothelial dysfunction, heart failure, Alzheimer's, Parkinson's, ALS, Huntington's disease, cancer prevention, chronic kidney disease, type 2 diabetes, metabolic syndrome, toxic liver disease, emphysema, asthma, pulmonary fibrosis, sepsis, autoimmune diseases such as rheumatoid arthritis, lupus, Crohn's, ulcerative colitis, inflammatory bowel disease, HIV, AIDS, multiple sclerosis, Tecfidera, and epilepsy. So this is quite a broad spectrum of diseases and organ systems affected. But again, I point back to the fact that what we're doing with Nrf2 activation is getting to the root cause of the problem, which is the oxidative stress. And that's why it has the potential to affect so many different things. So myself, being a cardiologist, obviously I was interested in the cardiovascular effects. And so this slide shows some of the things that have been found in scientific studies with regard to cardiovascular diseases. One is that Nrf2 helps to protect the endothelial cells against oxidative stress and inflammation. And that oxidative stress and inflammation is the very first step in the development of atherosclerosis. It can also help protect against ischemic injury by upregulating the phase 2 detoxification enzyme, specifically glutathione. Superoxide dismutase may play a role there too, and I remember one of the studies that I did in my cardiology fellowship was when we had patients who came in with heart attacks. We injected superoxide dismutase down their coronary arteries in an attempt to help reduce the size of the injury from the heart attack. Nrf2 helps to increase mitochondrial biogenesis, the powerhouses in the cell. It makes more of them in the heart muscle. It can help protect all parts of the cardiovascular system from oxidative stress. It can prevent right-sided congestive heart failure due to pulmonary hypertension, and it can prevent intimal hyperplasia and saphenous vein graft. That's the buildup of blockage inside a vein graft that's used for bypass surgery. All of those things have been shown in clinical studies with regard to Nrf2 activation. One of the studies on protandim looked at the effect that protandim had on atherosclerosis, on the genes associated with atherosclerosis. And in this case, there are 19 genes. 16 of them are modulated by protandim in the beneficial direction when you activate Nrf2 with protandim. So again, I can't state that protandim cures, treats, or prevents anything, but this is one of the studies that I would just point to for you to take a look at. Now, interestingly, Reata has this drug bardoxolone that was being studied in kidney failure that looked very promising. They ran into a snag in that they were, if you review the studies, they were giving it to some pretty sick people, and some of them had a lot of side effects, and they just ended up not being able to complete the study. So they turned their attention now to pulmonary hypertension with this drug bardoxolone. I haven't seen the final study, but it looks very promising, this drug for pulmonary hypertension, which is, again, a Nrf2 activator. But interestingly, this particular study, which is the one that really caught my attention with regard to protandim Nrf2 activation, predates Abbott's launch into the pulmonary hypertension market. This was a study that was done, published in Circulation, Journal of the American Heart Association, that looked at the effect that Nrf2 activation with protandim had on right heart failure. And what they found was that just having pulmonary hypertension does not necessarily cause right heart failure. But if you look at anybody with pulmonary hypertension, they almost all get right heart failure. They found that Nrf2 activation with protandim had a protective effect, and this was an animal study. But basically what they found was that their pulmonary pressures, even though they were high in all the groups, those that were on protandim, activating that Nrf2 pathway, had less fibrosis in the heart muscle. Their cardiac output, the amount of blood that the heart pumps out, was better with protandim. The capillary volume was better, and they didn't have cell death in the right ventricle. And that was a big deal. And I kind of think to myself that perhaps that might have had something to do with why Reata and Abbott decided to look into their drug bardoxolone in pulmonary hypertension. I don't know that for a fact, but that's kind of my own theories. So now they're looking at Nrf2 activation for a variety of different causes of pulmonary hypertension, and this particular artery actually talks about protandim being one of the treatments, in addition to carvedilol, which is a very well-known beta blocker. It's used for heart failure, and vitamin C. But what they found is that the protandim may help not only in the late stages, but potentially in the early stages where that oxidative stress is causing that initial injury to the blood vessels in the lungs. This was the study that protandim was shown to block that intimal hyperplasia in the saphenous veins. And these are some slides from that, just showing the intima, when exposed to high levels of oxygen, as you would see in arterial blood, thickens in an inflammatory response type method, but when treated with protandim, it completely prevented that intimal hyperplasia. I just want to finish up here by, got a lot of slides, but I'm not going to have time to get through all of them. Just want to get towards some of the more recent ones. This is a study that was actually done by a PhD graduate student at Mayo Clinic, potential therapy for ovarian cancer. And he had this patient who came in that had metastatic ovarian cancer and had gone through a round of chemotherapy, had a reduction in their CA-125 levels, then it started going back up. The individual declined chemotherapy for a second time and took protandim. Their CA-125 levels came down, but more importantly, the size of the tumors in their abdomen decreased just with that therapy. Again, we're not saying that this is a cure, treatment, or prevention for anything, but this has now prompted them at the Mayo Clinic to do more studies on the potential effect in ovarian cancer. A study from University of Montreal looking at Nrf2 activation in osteoarthritis, and their conclusion was that they found that the oral administration of protandim reduced cartilage damage, and they go through the biochemical pathways as to why that is. won't get into that here tonight. There's numerous studies on protandim. If you want to go look them up yourself, you can go to pubmed.gov and you can see what all has been studied. But don't just look at protandim, look at all of the other things that Nrf2 is being studied in and all the other compounds and so forth, and you can learn for yourself the vast nature of the types of things that Nrf2 activation can do. I'm just going to leave you with a couple of quotes here. In my anti-aging fellowship, I've had a couple of speakers who spoke about Nrf2, and this particular individual in April of 2014 said, Nrf2 is a revolution in science and is the most important anti-aging pathway in the human body. More recently, Oregon State University just did a study that talked about how Nrf2 activation can slow age-related diseases. And they talk about how when Nrf2 finds a problem, it goes back to the cellular nucleus, rings the alarm bell where it can turn on up to 200 genes responsible for cell repair, detoxification, carcinogens, protein and lipid metabolism, antioxidant protection, and other actions. And in the report, the scientists called it a longevity assurance factor. I love that term. I truly believe that Nrf2 is a longevity assurance factor. And I'm finally just going to leave you with this. We're right on an hour here. And I want to get you guys off in right on an hour's time. And in that study that I talked about from a year ago, this was one of their conclusions that they came up with. And they said that we may be on the verge of a new literature on the health effects of Nrf2, which may well become the most extraordinary therapeutic and most extraordinary preventive breakthrough in the history of medicine. And I truly believe with all the studies that we're seeing coming from so many different universities, that this thing is about ready to explode, this whole Nrf2 pathway. You're going to see a lot more out there about it in the very, very near future. So I'm glad you guys took some time tonight to get on this webinar to kind of scratch the surface of where we're headed with Nrf2. And I wish you guys all a wonderful evening. I'm going to be repeating this webinar at 9 p.m. Central Time. There's a link that you probably have seen for that if you would like to hear it again or if you've got other people that you would like to get on it. So thank you guys so much for your time and attention, and we will see you again soon. Bye-bye.